Hi everyone, thanks for tuning in. Our students are starting the third stage of the Energy Storage and Transport project.
Stage 3 is all about the experimental validation of the model that they have developed so far. Validation is an essential part of the modeling cycle, since it demonstrates to what extent the developed model represents reality.
Our students got a nice budget to set up a simple experiment to validate a part of their model. Let's see how they're doing.
Did everyone see the technical drawings that Pepper and I made for our experimental ID? Victor, you have explored options for the pump we can use in our experiment.
Yes, I found a few options which differ a bit in price and size. Of course, these pumps are a bit different from what we have in mind for our system, but our model is able to describe the behavior of these pumps.
That's good news, because we can partly validate our model based on these pumps. Are there any ideas on how big our setup should be?
I think we should keep it compact so that we can easily take it with us when we are not working with it. Besides, making it bigger makes it more expensive.
I think we should then go for the Mark II pump. It only costs about €10, but it's very suitable for small volume rates. The only thing we have to keep in mind is that it requires an external motor.
Shall we ask the teachers for their opinion about our plans?
Hi Group 42, how are things going?
We are just discussing our options for the experiment.
What are you planning to do?
As you know, we are working on a pumped hydroelectricity dam. Our model shows that the pump efficiency is very important, so that is what we want to focus on in our experiment. Victor, can you tell a little bit more about the setup we designed?
So we want to pump water from a lower level basin to a higher level basin using a centrifugal pump with an external motor. The idea of the experiment is that we want to measure the electrical power supplied to the pump and then to compare that to the amount of water being pumped to the higher basin. By comparing these two, we can assess the efficiency of our pump.
I like the idea. That efficiency that you compute, will that directly be useful for your model?
We have some doubts about that, because in the upscaling the efficiency might of course change. But what we plan to do is to determine the efficiency for a different Reynolds number, as our model also has the efficiency expressed as a function of that.
Good to hear that some thought went already into it. I like the direction you're going in. Are there any things you would like my opinion about?
We are thinking of keeping the setup small so we can easily store it, but at the moment it appears that we are underspending a little bit.
I think it's not bad that at this point you think that you will not be spending your full budget. You can use the remaining budget to improve your setup.
Do you have suggestions for improvement?
Sure. One thing might be to add an additional flow sensor to your setup so that you can better validate the flow losses in your system. That makes the experiment that you are going to do a bit more representative of the real system. Another thing is that if you want your experiment to be reproducible, you should build a very neat setup. That means that you might spend some extra money on some crucial components of the setup.
Thanks. We already had similar ideas. Good to know that we are on the right track.
Damn, those copper tubes and connectors are expensive. This way we will not be able to stay within our budget.
And the other stores are even a lot more expensive.
Can you find what you're looking for?
We are trying to build a hydrodam energy storage setup for our university project. But it seems that the copper tubing we are looking for is exceeding our budgets.
I think I saw something about that on TV. Are you those engineers of the future?
I guess that depends on whether we find a solution to our problem.
But that setup that you're trying to build, can't you use pneumatic tubes for that instead of copper? Of course, those are not as durable, but they're a lot cheaper.
Where can we find that?
In aisle 23. Let me show you.
That's indeed a lot cheaper. This does fit our budget.
Did you already think about how you're going to connect the tubes to your water containers?
We thought about just drilling a hole in them.
If you do that, you will have to work very neatly, because if you don't, the plastic will break. You might want to consider reinforcing the plastic first at the locations where you're going to connect the tubes.
Thanks for the advice. We will do that.
And, of course, make sure to work safely.
Good afternoon.
How may I help you?
We are looking for a flow sensor to connect to an Arduino Uno. I have written down some specs. Could you recommend a sensor to us?
Let me check our website. We have the FlowRate 2000, which seems to match your specs. It costs €5. The only thing I'm not sure about is the time resolution. Do you know what resolution you require?
If it measures at an interval of a few seconds, that should be good enough.
That should work. I just wanted to check if you don't get aliasing in your measurement.
Tony, was there anything else we needed?
I'm not sure. We already bought an electromotor to power a little pump. So I guess we just power that through our Arduino?
In that case, we also sell fire extinguishers. Just kidding, I mean that kind of current cannot be supplied by your Uno board, unless you try to fry it. What you will need is an external power source and a controller to connect your Arduino. Let me check what we have in store. Do you happen to know the power of your motor?
Amazing work, guys. That looks really good. Is it all connected to the laptop already?
Yes, it will start with one click of a button.
What are we waiting for? It works. Is the data coming in?
Yes, it is. It looks very good. The only thing that is weird is that our water level sensor seems to be out of range.
That is probably the sensor range issue that we were already doubtful about. I think if we get that other sensor at Picotronics, we should be good.
Okay. Will you get that sensor?
Yes, I will be back within an hour.
In the meantime, we can check whether all other measurements make sense.
Looks like that group has it all under control. I'm looking forward to seeing the results in their technical report.
Indeed, Elisa. They also have ample of time left, so they can really fine-tune their experiment and can reproduce it multiple times to make their validation process very sound. I hope they also take the time to properly document everything.
I'm sure that by now they know that all instructions can be found on the Canvas assignment page. If they carefully review the rubric, they should be fine.
And let's hope they carefully review each other's contributions to the report so that the academic quality of the report meets our expectations.
Indeed, we'll find out soon enough. We'll let them get back to work as they still have a lot to do.
That's right. Bye bye!